Preparing for a software engineering at Goldman Sachs interview. You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Given a stream of stock trades, how would you find the top K most traded symbols efficiently? I would maintain a hash map from symbol to trade count, because updates are O1 on average. To return the top K, I would use a min heap of size K, keeping only the most active symbols. For batch processing, this gives O(n) log K. For a live stream, I would discuss periodic recomputation or indexed heap updates. The key trade-off is accuracy versus latency, especially if the stream is distributed. While answering, focus on hash maps for counting, heap-based top K selection, streaming updates, time and space complexity, and how you would handle very large or continuously arriving trade data. Question 2. Explain how you would design a thread-safe order book for a trading application. An order book needs fast inserts, deletes, and best bid or ask lookup. I would store bids in descending price order and asks in ascending order, with queues at each price level for time priority. For thread safety, I would start with fine-grained locks around price levels or book sides, then measure contention. In latency-sensitive systems, immutable snapshots or single-writer event loops can reduce locking complexity. Correctness matters more than premature lock-free code. Make sure to cover bid and ask data structures, price time priority, concurrency control, locking versus lock-free approaches, consistency guarantees, and why low latency matters in financial systems. Question 3. What is the difference between an interface and an abstract class in Java? And when would you use each? An interface defines a capability or contract, while an abstract class can define shared state and partial implementation. I use interfaces when unrelated classes should expose the same behavior, like pricer or risk calculator. I use abstract classes when subclasses share common logic, fields, or lifecycle behavior. Since Java supports multiple interfaces but only one superclass, interfaces are usually better for flexible design. Abstract classes are useful, but they create stronger inheritance coupling. In your answer, talk about contracts versus shared implementation, multiple inheritance of type, default methods, constructors, state testability, and how these choices affect extensible enterprise codebases. Question 4. How would you detect a cycle in a linked list, and why is Floyd's algorithm preferred? Floyd's cycle detection uses 2 pointers. Slow moves 1 step, fast moves 2. If there is a cycle, the fast pointer eventually catches the slow pointer inside the loop. If fast reaches null, there is no cycle. The benefit is O of n time with O of 1 extra space, unlike a hash set approach. In an interview, I would also handle edge cases like an empty list or a single node pointing to itself. Be sure to mention slow and fast pointers. Proof intuition, O(n) time, O1 space, edge cases like empty lists, and comparison with using a hash set. Question 5. How do database transactions ensure consistency in a financial application? Transactions group related database operations so they either all succeed or all fail. In a financial system, debiting one account and crediting another must be atomic. A partial update creates incorrect balances. ACID gives atomicity, consistency, isolation, and durability. I would choose an isolation level based on risk. Stricter isolation prevents anomalies but reduces concurrency. I would also design idempotent operations and use clear audit trails, because correctness and traceability are non-negotiable. While answering, cover ACID properties, isolation levels, commit and rollback behavior, double entry style updates, race conditions, deadlocks, and why partial writes are dangerous in money movement systems. Question 6. Write an algorithm to find the first non-repeating character in a string. I would solve this in 2 passes. First, count each character using a map or fixed size array if the character set is known. Second, scan the string again and return the first character whose count is 1. The time complexity is O of n, and space is O of 1 for fixed ASCII, or O of k for the number of unique characters. I would clarify case sensitivity, white space handling, and what to return if no such character exists. Make sure to discuss using frequency counts, preserving order, handling Unicode versus ASCII assumptions, two-pass solutions, complexity analysis, and how you would communicate edge cases clearly. Question 7. What happens internally when you put an object into a Java HashMap? HashMap computes the key's hash code, spreads the bits, and maps it to a bucket index. If the bucket is empty, it stores the entry. If not, it compares keys using equals to update or append. Collisions are handled with linked lists, and in modern Java, heavily collided buckets can become trees. When the load factor threshold is crossed, the table resizes. Good immutable keys are essential because changing a key breaks lookup behavior. In your answer, cover hash code, equals, bucket indexing, collisions, resizing, load factor, treeification in modern Java, and the importance of immutable keys. Question 8. How would you design a REST API for submitting and querying trade orders? I would model orders as resources. Post orders to submit. Get orders, get ID to retrieve. And get orders with filters for account, symbol, or status. Submission should validate inputs, authenticate the caller, and use an idempotency key to prevent duplicate orders on retries. Responses need clear status codes and structured errors. Query endpoints should support pagination and sorting. For financial APIs, audit fields, correlation IDs, and versioning are important from day one. Be sure to mention resource modeling, HTTP methods, status codes, validation, idempotency keys, authentication, pagination, error format, auditability, and versioning for enterprise clients. Question 9. Explain the difference between optimistic and pessimistic locking. Where would each fit in Goldman Sachs-style systems? Pessimistic locking assumes conflicts are likely, so it locks data before modification. That is safer for critical sections like updating a limited inventory or sensitive balance record, but it can reduce throughput. Optimistic locking assumes conflicts are rare. It updates using a version field and retries if the version changed. I prefer optimistic locking for high-read, low-conflict reference data. For money movement, I would be conservative and choose the model based on correctness, contention, and latency requirements. While answering, focus on conflict assumptions, database row locks, version columns, retry logic, throughput impact, deadlocks, and examples such as account balances or reference data updates. Question 10. How would you approach debugging a production latency spike in a market data service? I would first confirm the symptom with dashboards, P95 and P99 latency, error rate, throughput, CPU, memory, GC, and queue depth. Then I would check recent deployments and downstream dependencies. Distributed traces help identify whether latency is inside the service, database, network, or external feed. If customer impact is high, I would roll back or route traffic before deep investigation. Afterward, I would write a postmortem and add better alerts or capacity guards. Make sure to cover metrics, logs, traces, recent deployments, dependency checks, thread dumps, garbage collection, queue depth, rollback strategy, and communicating impact during an incident. Question 11. What is dependency injection, and how does it improve testability in enterprise Java applications? Dependency injection means a class receives its dependencies instead of constructing them directly. For example, an order service should receive a risk client and order repository through its constructor. That makes the service easier to unit test because I can pass mocks or fakes. It also reduces coupling and centralizes configuration, especially in Spring applications. I prefer constructor injection because dependencies are explicit and immutable, which makes the code easier to reason about. In your answer, talk about inversion of control, constructor injection, mocking dependencies, Spring-style applications, loose coupling, configuration management, and avoiding hidden object creation inside business logic. Question 12. How would you find the median from a continuously arriving stream of numbers? I would use two heaps. The lower half goes into a max heap, and the upper half goes into a min heap. On each insert, I place the value into the correct heap, and rebalance so their sizes differ by at most 1. If the total count is odd, the median is the top of the larger heap. Otherwise, it is the average of both tops. Insert is O log n, and median lookup is O1. Be sure to cover the two-heap approach, max heap and min heap roles, balancing rules, insertion complexity, median retrieval, and how this pattern applies to streaming analytics. Question 13. Explain how garbage collection can affect a low-latency Java application. Garbage collection reclaims unused memory, but some phases can pause application threads. In a low-latency service, even a short stop-the-world pause can violate P99 latency targets. I would monitor allocation rate, heap usage, pause times, and promotion patterns. Reducing object churn, reusing buffers carefully, and choosing an appropriate collector like G1 or ZGC can help. The goal is not just higher throughput, it is predictable latency under realistic load. While answering, focus on heap allocation, stop-the-world pauses, GC algorithms, object churn, profiling, tuning, memory leaks, and coding practices that reduce allocation pressure. Question 14. How would you implement an LRU cache, and what operations must be O1? An LRU cache evicts the least recently used item when capacity is reached. I would combine a hash map with a doubly linked list. The map gives O1 access from key to node, and the list maintains recency order. On get, I move the node to the front. On put, I update or insert, then evict from the tail if needed. If multiple threads use it, I would add synchronization or use a concurrent design. Make sure to mention HashMap plus doubly linked list, get and put behavior, eviction policy, capacity handling, updating recency, and thread safety considerations if shared. Question 15. What SQL query would you write to find the second highest salary in an employee table? A simple approach is selecting distinct salaries, ordering them descending, and taking the second row. For example, in many databases, select distinct salary from employee, order by salary desk, limit 1, offset 1. Distinct matters because multiple employees may share the highest salary. Another option is a subquery finding max salary less than the overall max. I would clarify what should happen if there is no second salary and adapt syntax to the database. In your answer, cover distinct handling, order by with limit or offset, subquery alternatives, null result behavior, ties, indexing considerations, and adapting syntax across databases. Question 16. How would you design a system to process millions of end-of-day trade records reliably? I would design the pipeline around reliability and replayability. Trade records can be partitioned by date, region, or account, then processed in parallel workers. Each stage should validate input, write checkpoints, and produce idempotent outputs, so retries do not duplicate results. Failed records should go to a dead letter path with clear reasons. At the end, I would reconcile counts and totals against source systems. For finance, auditability is as important as speed. Be sure to discuss batch processing, partitioning, queues or files, validation, retries, idempotency, checkpoints, reconciliation, observability, and failure recovery for financial reporting workloads. Question 17. What is the difference between a process and a thread, and why does it matter for backend services? A process has its own memory space, while threads within a process share memory. Processes give stronger isolation, but inter-process communication is heavier. Threads are lighter and useful for concurrent work, but shared state introduces race conditions and synchronization complexity. In backend services, thread pools help control concurrency and resource usage. I would avoid creating unbounded threads because it can increase context switching, memory use, and latency under load. While answering, cover memory isolation, shared address space, context switching, communication cost, failure isolation, concurrency, thread pools, and practical impact on server performance. Question 18. How do you ensure a service remains idempotent when clients retry requests? Idempotency means repeating the same request has the same effect as sending it once. For a create operation, I would require an idempotency key from the client and store the key with the request result. If the client retries, the service returns the original response instead of creating another order or payment. Database unique constraints can enforce this. I would also define key expiry and make sure retries are safe across service restarts. Make sure to cover idempotency keys, request deduplication, safe retry semantics, database constraints, response replay, time windows, and why retries are common in distributed systems. Question 19. How would you solve a coding problem where you must merge overlapping intervals? I would first sort intervals by start time. Then I would scan from left to right, keeping a result list. If the current interval starts before or at the last result interval's end, they overlap, so I update the end to the maximum of both ends. Otherwise, I append a new interval. Sorting dominates the complexity at O of n log n, and the scan is O of n. This pattern appears in calendars, maintenance windows, and trading sessions. In your answer, discuss sorting by start time, iterating once, comparing current start with previous end, merging boundaries, complexity, and examples involving booking or trading windows. Question 20. Tell me about a time you improved the reliability or performance of a software system. I would answer with a specific story, not general claims. For example, I noticed a service had rising P99 latency during peak traffic. I profiled it, found repeated database calls inside a loop, added batching and caching, and introduced metrics to verify the fix. The result should be quantified, such as reducing P99 from 800 milliseconds to 180 milliseconds. I would also explain the trade-off and how I ensured correctness before rollout. Be sure to structure this as situation, task, action, result. Include measurable impact, technical depth, trade-offs, collaboration, ownership, and what you learned from the experience. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.